Good morning, students. Today we will start a new chapter, which is the last chapter, which is interpolation. Now, what is interpolation? So, interpolation. Now, let's say y equals to fx. We have a function y equals to fx, but fx is, we don't know the combination of fx, that is the function is unknown, but we have some values of the function at some points. Okay, so for a function y equals to fx, x is called the independent variable. Okay, independent variable. Independent variable, and y is dependent variable. Now, for some independent variable x, known values of x, we have given the value of the function fx. Okay, but the function is not given. Then in this case, we want to find, for some value of x, we want to find the function of the value of the function at that point, other than the given values of the function. Okay, that is, we say x1, x2, x3, x4 up to xn. For some values of x equals to x1, x2, x3, we know the values of the function, that is y1 equals to f of x1. So corresponding to the values of x1, we know the value y1, it is given, and f of x2 also, y2 equals to f of x2, y equals to f of x3, y3 equals to. Okay, so these values are known. Similarly, yn equals to f of xn. But we want to find the value of fx at some point x equals to x star. Okay, so x star is different from the given values of x. So at that point we want to find the f of x star, but we don't know, that is the fx is not given, only the values of the function at some specified point is given. So in that case, if x star lies between in this range, that is x1, x2, x3 lies between this range, okay, then it is called the interpolation problem. Okay, if x star lies outside the range of the values of x, then it will be called the extrapolation problem. Okay, such as in another example, if we know that x and fx is given for some point, let's say for 1 f of 1, let's say whenever x is 1, f of 1 equals to 3, whenever x is 2, f of 1 equals to 5, 3, this is 7, 4, this is 9. Okay, these four values, for these four values of x, we have the values of the function in this form. Okay, so f of 1 equals to 3, f of 2 equals to 5, f of 3 equals to 7, f of 4 equals to 9. Now we want to find a value of fx at x equals to, let's say, 2.5, or at x equals to 1.5. Okay, so we have to find the values of fx at a unknown values of x, which is not given. Okay, also we don't know the fx. What is fx? We just only know the values of fx at some particular points. Okay, now in this case, it will be called the interpolation problem. We will use the interpolation problem to solve this. Okay, now so first and important rule is, for interpolation problem fx is not given. Okay, so every function have a graph. Okay, every function have a graph. Now we will try to approximate this graph with a polynomial. Okay, how? কিভাবে? Now for this function we know that this is the, let's say, x1 x2 point, x1 point, okay, x1 y1 point. For this function it is known x2 point, this is x3 y3. Let's say for some values these are the known. Okay, so these are x1 y1, this is x2 y2, this is x3 y3, this is x3 x4 y4. Okay, this in this point the function, we know the value of the function. Now we will try another function which we know. Okay, which we know and have the same value as the given function have. Okay, so this is the given function fx. We will approximate this fx function by a polynomial function px. So this px has the same values as it is given. Okay, and it is approximated to the given function. Okay, so in the interpolation problem we will approximate the function fx by a polynomial, and then whenever a polynomial is known we can find the unknown values at a unknown point. Okay, so the value will be approximated also. So this problem is called numerical problem. So in numerical problem it is the values are always approximated at some given desired points. Okay, we will not find the exact value of the function. Okay, now to find the polynomial corresponding to approximated polynomial corresponding to a given function which are known for some given points. Okay, we will use, there are many methods. Okay, first, to find the polynomial, first we have to learn the two concepts. One is the difference, finite difference method. Second, shifting property, the shifting operator. Also this is known as the difference operator and shifting operator. And on another question, another part is entry and argument. The values of x, when for some values of x in the intermediate from, okay, intermediate values of x, that is x1 x2 x3 xn x4 xn, these are called the entry, and the corresponding values of y1 values of fx at x1 x2 x3, that is y1 y2 y3 y4 yn, these are the called the argument of the given data. Okay, now difference method. Let's say we have a given, to find the difference operator and shifting operator, first there are two types of table will be given. Okay, there are two types of entry and two types of argument. Okay, first two types of entry, if the entry are in equidistance, that is the difference, that is x1 and x2 lies in the equidistance of the other. Okay, that is x2 minus x1 will be whatever be the x2 minus x1, that will be equals to x3 minus x2, that will be also equals to x4 minus x3. So in this case, this given data are will be called in equidistance form. If they are not in the equidistance, then we will use the different method. Okay, so first we will discuss for the equidistance case. Okay, so if the data x1, x2, x3 xn are in equidistance form, then we can write x2 minus x1 equals to d, x3 minus x4, x4 minus x4 minus x3 minus x2, x4 minus x3, x5 minus x4, and up to. Okay, in the general case we can write xn into xn minus 1 equals to d. Okay, so and the corresponding arguments are y1, y2, y3 up to yn. That implies xi equals to yi equals to f of xi. Okay, so these are the given values for I equals to 1, 2 up to n. Okay, these are the given data for equidistance case. Then the difference operator is given as del of f of xi. Okay, del of f of xi equals to f of xi plus h minus f of xi. H means here d, the distance, equidistance. Okay, so in the general case, if we do not use the xi, so del of fx operator is f of x plus d minus f of x. Okay, so this is the forward difference operator. So in this case we can find the del square of fx equals to q, right? Del square of x can be written as del of fx equals to del of f of x plus d minus del of fx, right, minus del of fx, del of f of x plus d. So del of f of x plus d minus del of fx, that implies f of x plus d minus f of x plus d minus of del fx mean f of x plus d minus f of x. Okay, so that implies del of f of x plus 2d minus 2f of x plus d minus plus fx. So this is the delta square of fx. Okay, so in this way we can find the another del cube fx, that is in third order difference. This is first order difference, this is second order difference, this is third order difference. So in this way we can find the others higher order difference of the given data, given table. Okay, so whenever this type of data is given, we first find the difference table. Okay, so using the difference method, difference operator, we will find the difference tables in this form as, let's say, difference table. Let's say we have the given value as x1 equals to 2, x2 equals to 4, x3 equals to 6, x4 equals to 8. Okay, and corresponding y1 equals to, that means f of x1, right? F of x1 equals to, let's say, 7, y2 equals to f of x2 equals to let's say 14, y3 equals to f of x3 equals to let's say 21. Okay, let's say this is 15, this is 21. Y4 equals to f of x4 equals to, let's say, 30. Okay, so this kind of data is given. So how to find the difference table? So okay, we will first write the entry. Here the given data, given entry are in equidistance form. So we will write data in this form. This is x, this is f of x. So x is given 2, 4, 6, 8, and the corresponding arguments are 7, 15, 21, 30. Okay, now first we will calculate delta fx, that means first difference. So first difference is 15 minus 7, which is 8, 21 minus 15, which is 6, 30 minus 21, which is 9. So this is the values of the first difference. So this is if it is x1, x2, x3, x4, then delta f of x1. Okay, delta f of x1 is this value, delta f of x2 this value, delta f of x3 this value. Okay, so this, if y1 is this, y2 this, y3 this, y4 equals to this, so delta y1 means delta of f of x1 equals to 8. This is delta of y2, this is delta of y3. Now next, delta square f of x. So that means the difference between this, the 6 minus 8 is minus 2, 9 minus 6 equals to 3. Okay, so and lastly delta cube fx, that means 3 minus 2 minus 5. Okay, so this is the difference table. So in this way we will find the difference table, and this value will be used for some difference method, interpolation method, to finding the values at the unknown entry, values of the fx at the unknown entry, which lies between the range of the given range of the entry. Okay, so this is difference table. Now another is shifting property. So difference method, for the method of difference, it is known that if delta of fx equals to f of x plus d minus fx. We know this formula, and the shifting property is e of fx equals to f of x plus d. Okay, so whenever we use the e operator, this is shifting operator, this is difference operator. So e of fx means the value of the function at the next values. Okay, as we know x2 minus x1 equals to d, then x1 equals to x2 equals to x1 plus d. So the next value x1 plus d represents the next value. So whenever we use x1, this is, let's say, x1, then x1 plus d, that means f of x2. Okay, so in argument form, delta y equals to let's say delta y1 equals to y2 minus y1. Okay, delta y2 equals to y3 minus y2, and similar. And shifting property, e of y1 equals to y2, e of y2 equals to y3. Okay, this is shifting property. So using those two we will get, and also e2, if it is e2 fx, e square of fx, that means e of fx, that means e of f of x plus d, that means again using shifting property f of x plus d, f of x plus 2t. So it shifts the two entry values of the two entry. So e square of y2 means y4, e square of y6 means y8 if the values of the entry are given. Okay, so using this property we will find a relation between difference and shifting operator. Relation between difference and shifting operator. So we have delta of fx equals to f of x plus t minus f of x, right? And e of fx equals to f of x plus t. Okay, so we can write delta fx equals to e of fx minus fx. So if we take common, so first we will find e minus 1 fx. So delta of fx equals to e minus of 1 fx. In similar way, we can find delta square fx equals to e minus 1 whole square fx. Delta cube fx equals to e minus 1 whole cube fx up to the nth difference equals to delta to the power n fx. Okay, so this is the relation between the shifting property and difference, shifting operator and difference operator. When we find the Newton forward and backward formula, we will use this method. Okay, we will use this formula to find the Newton forward and backward formula. Okay, that's it for today. In the next class, I will explain the next formula to find the interpolation polynomial. Okay, and that's it for today.